second to tell me kind of what his challenges are that he's feeling with this section. So with this section, obviously we've moved into inferential statistics and hypothesis testing. And I think it's important for you guys to kind of remember that the steps that you're going to use for every statistical test in this unit and in the unit to follow are exactly the same. So it's not listed as a step, but I guess the first step is really to identify which statistical test is appropriate given the design that's expressed in the question, right? Mm-hmm. Once you know the statistical test that's appropriate, then you follow 4 steps. The first step is to identify the null hypothesis and the alternative hypothesis. It's easiest, I think, to start with the null hypothesis when it's a non-directional hypothesis. So the null hypothesis always says that there's no difference. The alternative hypothesis says that there is a difference. And if it's a directional hypothesis, the alternative hypothesis tells you what direction that difference goes in. So when the question is suggesting that one group or one condition or whatever it is bigger than or smaller than the other, that's what cues you in to know. As soon as you know it's directional, it's easiest to write the alternative hypothesis first. So the alternative hypothesis says group A is going to be bigger than group B. The reason that's important to write first is because the null hypothesis then expresses all of the possible opposite effects. So if the alternative hypothesis is saying group A is going to be bigger than group B, then the alternative says, no, that's not right. Group B is either going to be less than A or they're going to be equal. So when it's a directional hypothesis, start with the alternative and then make the null hypothesis everything else. When it's a non-directional hypothesis, you can start with either one, but criterion value is. And the criterion value is the point on the distribution above which or below which, if your test statistic falls above that or below that, depending on if it's directional or non-directional, if it falls in the critical region, that's the best way to say it, then you're going to reject the null hypothesis, the alternative. So you identify the critical region. Yeah, so the critical region or the critical values determine the critical region. The critical region is that region that's off to the end in the distribution. It's either in one end or it's in both ends, right? And if when you calculate your test statistic, it falls in that critical region, either one of the two ends or just the one end, then you would reject your null hypothesis. And your conclusion statement would then start with your alternative hypothesis, and you would write your conclusion statement in terms of your alternative hypothesis. But if when you calculate your test statistic, you're not in the critical region, you're somewhere more in the middle or somewhere more in the end that doesn't have the critical region, then you would fail to reject your null hypothesis. And you would essentially keep your null hypothesis, and your conclusion statement would be written as a null hypothesis with the necessary additions, which I'll talk about in just a minute. So you write your null hypothesis, you write your alternative hypothesis, you identify your critical region. Your critical region is determined based upon alpha and whether it's one-tailed or two-tailed. And then if it's for a t-test, you also need to know degrees of freedom. So you just look up the critical value in the back of the book, given alpha, whether it's one-tailed or two-tailed, and if it's a t-test, what the degrees of freedom is. And that's your critical value that determines your critical region or regions, okay? Then in step 3, you actually calculate the test statistic. And let me screen share real quickly to make sure you guys have seen this formula sheet that you'll have available to you during the test. And this really gives you all the formulas that you need. It gives you formulas for variance or standard deviation in the first column, for standard error, which you need because that goes in the denominator when you calculate the test statistic, which is in the third column. And then it also tells you what your degrees of freedom are. So it shows it for each of the 4 tests that you're going to be asked to do. And what's good for you guys to notice is that if you look over here in test statistic, the numerator is essentially always the same thing. It's always comparing the mean of your sample to either the population mean, that's what it is in the z-test and the t-test, or it's comparing, and actually in the dependent samples t-test as well. But in that case, I'm getting ahead of myself. In that case, this mu sub d becomes 0. Or you're comparing the mean of sample 1 to the mean of sample 2 in an independent samples t-test. So the numerator is always the same. It's comparing the means that you have to some known mean, the population mean, or an expected mean difference of 0. And then the denominator is always standard error. So it's always coming from this column. You're going to calculate standard error, and that goes in the denominator. And that's true for all 4 of these. So I just kind of wanted to show how those are all very similar conceptually. And so you calculate your test statistic, and then in step 4, you make your decision. And you make your decision based on comparing your test statistic to your critical value. If your test statistic puts you in the critical region, then you reject the null. And if you reject the null, then you're going to write a conclusion sentence that is your alternative hypothesis, but with the word statistically different, or statistically bigger, or significantly bigger, or statistically significantly bigger, anything like that, all right? Because it suggests that you've done a statistical test. I guess the best choice is significantly. I apologize. The best choice is significantly. So if you reject the null, you would say there is a significant difference between group A and group B, and then you would put a comma. The way I just described it would be an independent samples t-test. So you'd put t, parentheses, degrees of freedom, equals the value you solved for, the test statistic you solved for, and then comma, p less than 0.05. If you say it's a significant difference, it always has p less than 0.05. If it's not statistically different, significantly different, then you say p greater than 0.05. So those always go together. That's a one-to-one relationship. So I don't know if that, Andrew, we had a chance to talk beforehand. I don't know if that helps to sort of help you conceptualize what you're doing. The math, the math is just following the formulas. And I don't mean to trivialize that, but you'll have the formulas in front of you. If you've been practicing, then I think it's pretty straightforward. The thing that you have to remember is that you have to remember that you don't stop at standard deviation or variance. You have to take that next step to get standard error. Like that's an important step to remember that people sometimes forget. And to me, the other big challenge is just knowing which test you need to use. So let me pause there and see if that.
No, that definitely kind of unmuddied the waters a little bit.
Okay. So, in terms of, well, other people have joined in now too. And I know some of you guys didn't hear all of this, but David, you did. Do you have questions to follow up sort of on what I just said, or?
No, not necessarily. I was a little confused, I guess, with the directional hypothesis. And I think it's a few times I was reversing the null instead of using directional.
Okay, yeah. Right, like I said, if it's directional, you'll know it's directional because in the question it'll have a direction in the question, like bigger than, smaller than, more than, improves, decreases. Those kinds of words are suggesting a direction. If it's non-directional, then the words are really just difference, or I expect my treatment to have an effect, and I'm not predicting a direction. When it's directional, the real key is to write your alternative hypothesis first. What does the researcher expect to happen? And write that in words. And then you can identify the null hypothesis because it's all the other possibilities. So if the researcher expects their treatment to improve some variable, then the alternative hypothesis would say the treatment will improve whatever. And the null hypothesis would say everything else that's different than that. So the treatment will have no effect or will actually cause a decrease in or a detriment to whatever. So it's all of the possible opposites. Now, all of this being said, when you do the test, I'm not going to actually ask you to write out the null and alternative hypothesis. I'm expecting that people have a handle on that, and I'll know if they have a handle on it when I see their conclusion sentence. So the test actually asks you to identify which test statistic you're going to use, and then essentially I need the critical value too. So that's the one thing that comes from step 1. But after that, it's just steps 2 through 4 that you're asked to do on the test. So you don't actually have to take the time to write out the null and alternative hypothesis in words or symbols. You kind of start right after that step and do everything else. So the other thing that becomes challenging and that will stay challenging from this point forward really is knowing which test to use. And I posted in the modules section a PowerPoint presentation that gives you a chance to practice on that. The other thing that I would suggest doing is to use the worksheets to practice. So the worksheets help you solve the problems, and there's answers and all of that, but you can also use those worksheets just to get additional practice in identifying which test you need to use. So I would even suggest, if that's a challenge for you, getting all the worksheets, literally cutting them, and then mixing them up so that you don't, actually before you cut them, turn them over and write what the answer is on the back. Which type of test was this? Was this from the z-test section or the single sample t-test, independent sample or dependent? And then cut them up, mix them up, and that gives you a good way to just practice. Can I identify which test to use just from reading the question? But as a review, the z-test is used when you're comparing a sample to a population, and you have some measure of variance for the population. That could be variance or standard deviation, but you have some known variance of the population. Single sample t-test you use in the same scenario in that you're comparing a sample to a population, but you go to look for variance for the population and you realize, oh boy, I don't know the variance or the standard deviation for the population. And that's your signal as soon as you reread the question and you go, oh, they didn't tell me variance or standard deviation for the population. Then you should be going, okay, single sample t-test. The next 2 sets of t-tests that you learned are both going to be where you have data from 2 groups or 2 conditions, like a pre-post or a group A, group B. It's independent samples t-test if those 2 groups are independent from one another. So one group was randomly assigned to get exercise, the other group was randomly assigned to a control condition. Well, those are different people in the 2 groups, so they're independent. Dependent samples t-test is when the 2 groups or the data from the 2 samples or groups or conditions or however it's described are related to each other in some way. The most common way you'll see it is if it's like a pre-post design. So I had 20 people, I measured something prior to a treatment, I gave them all the treatment, and then I measured something after the treatment, but it's the same people, right? The other one that's a little bit tricky and harder for people to catch, I think, is when it's like a matched design. And I know that's harder for people to conceptualize, but statistically, if there's a reason to think that the 2 groups are related to each other, you get the advantage of using a dependent samples t-test. So if it was some kind of a matched design where you took 40 people and you matched people, so I said, okay, who are the two people who do the best on my cognitive test? I'm going to match those, and I'm going to put one in one condition and one in the other. Well, then those people are related to each other because they share the ability to perform well on the test. So a matched design is another one where you would use a dependent samples t-test. The most common time that you'll see it, and it's not common, but the most common time that you would see it is like in twin studies, where they're trying to make sure that the people are as much alike as possible. So they'll take identical twins, and one identical twin gets this treatment, and the other identical twin gets this treatment. Well, clearly those people are related to each other. So you treat those as dependent samples and would do a dependent samples t-test. If it's a dependent samples t-test, then you start with the data and you calculate difference scores. For every pair of matched data, you calculate the difference score, and then you throw the original data away and you do everything with the difference scores, just as if it was a single samples t-test. Does that make sense? So it's, in some ways, a dependent samples t-test is really easy. As soon as you know it's dependent samples, you take the original data, you subtract and get all the difference scores, you use the difference scores, You throw away that original data and you just treat those different scores as a single sample. You do it just like a single sample t-test. With an independent samples t-test, I know that one is much more complex because of the fact that you have to calculate pooled variance. But if you just use that for, like, don't let it freak you out. Just use the formula sheet, calculate pooled variance, and then use that SP squared in the next step to get standard error. And then that just goes in the denominator, just like on the other 3 tests you're doing. So again, let me pause there and see if that prompts questions for people. Erica, I don't know when you joined us. Melinda and Dana, I know you heard all of that last part. So if you guys have questions, just chime in. Let's see, there's one, if you have questions, just jump in anytime, but there's one, and I'm trying to look for a, I got a question from Greg. Let me see if I can screen share that so I can talk you through that. Here it is. So Greg was asking a question about, can you guys see that? Mm-hmm. He was asking a question that comes up on some of the quizzes. I should, and actually let me back up for a second, because let me tell you a little bit about the design of the test. I'm going to answer this question, but you're not going to see questions exactly like this. But let me just tell you a little bit about the design of the test. So the test has a few multiple choice questions at the beginning. I think it's 6, if I remember correctly, that are just asking you to identify the statistical test that you should use. So it's from the 4 choices. You'll choose z-test, single sample t-test, dependent sample t-test, or independent sample t-test. So there's, I think it's 6 multiple choice questions that ask you to do that. Then there are 4 questions where you have to actually solve the problem. All right, 4 questions where you actually solve the problem. So think about that, everyone. Big, big hint. 4 questions, and you know how to do 4 statistical tests, right? So literally, if you are doing the test and you think you're doing 2 independent samples t-tests, you've probably made a mistake on one of them, okay? There should be 4 and 4, 1-to-1 match, okay? There's one question that's a conceptual question that is going to ask you something to make sure that you understand sort of the concepts. I won't tell you exactly which one, but it's in the area of thinking about error and power, okay? Thinking about the types of errors you might make when you make a decision in statistics, and or power, okay? So it's in that area, so take some time to look back at that conceptually. And then that actually ties in really well to this question. Let me pull the screen share back up here. Because this question, I don't know if Greg realized it or if other people realized it when you're asked this question. This question is actually asking about statistical power. So the question is, which of these choices is going to produce the largest value for the t-statistic? Well, the largest value of the t-statistic, that's how you increase statistical power. That's one way to increase it, because you're increasing your likelihood of correctly rejecting a false null hypothesis. So as you make the t-statistic bigger, you're benefiting statistical power. So the ways that you benefit statistical power are to, if you think about those formulas, think about the numerator. The numerator has the difference between the means. So one way that you can increase any statistical test is to increase the size of the numerator, because that's going to make the test statistic bigger, right? If you make the numerator bigger, whatever you're solving for, z or t, is going to get bigger. So to make the numerator bigger, you want to make the difference between the means bigger. Okay, so stick that in the back of your mind, and then we'll look at the choices in just a second. The denominator for the test statistic is standard error. And standard error is a measure of variance, either standard deviation or variance, over square root of n, essentially, square root of sample size. So that denominator, you want to actually make smaller, right, so that the test statistic would get bigger. If the denominator gets smaller, the test statistic's going to get bigger. Well, the denominator itself has a numerator and a denominator. To make the overall denominator smaller, you would either reduce variance or increase sample size. You guys with me? Let me stop this one more second and go back to the formulas. Hey, where'd my formulas go? Rats. Hold on just a second. I'm sorry. Let me pull the formulas back up. Screen share. Okay, here they are. So if you look over here at the test statistic, they're all the same as I talked about right at the beginning. The numerator is some expression of mean difference. The denominator is standard error. Standard error are these things over here, a measure of variance over a measure of sample size. So if you want to make the denominator smaller, you either make the variance smaller or you increase the sample size. Either of those things will make this smaller. So could you guys see that, or am I just talking it and not, you're not seeing it?
Yeah, we can see it.
Okay, super. So we go back to this question that Greg was asking. So in these choices, you're essentially looking for the choice where the mean difference is the biggest, the variance is the smallest, and the sample size is the biggest. In this particular question, the choices that they give you only focus on mean difference and variance. So if I look at variance first, in the top two choices, the variance is the same, right? It's sums of squares equals 10, sums of squares equals 10. So that's a pretty small variance. In the next two choices, the variance is bigger, sums of squares equals 50 for both of them. So I want variance to be small so I can immediately throw out these bottom two choices and come up here. So now when I'm looking at these two choices, now I'm going to find out which one has the bigger mean difference. So the bigger mean difference comes from the one where, let's see, here's mean is 30 and mean is 35 in choice A, and in choice B, the mean is 30 and the mean is 50. So the choice that gives me the biggest mean difference and the smallest variance is choice B. So that's the one that if I knew sample size, I could calculate and I would show, oh, it's got sample size up here. So you could actually calculate it if you wanted to, but what you would find out is that choice B is the one that gives you the biggest t-statistic. So it's a question that's really getting you to think about power and what are the factors that influence power. And power means is defined partly as, well, it's defined as your likelihood of correctly rejecting a false null hypothesis. It's influenced by your t-statistic. It's also influenced by your critical region, which would be another way to increase power is to influence your critical region. So questions about that? So I think, I mean, that's all I can think of as a way to sort of help you guys and try to reassure you that you probably know what you're doing. I think the challenges are identifying the correct test. Remembering the steps isn't that hard. And I mean, I kind of have them I think I have them explicitly listed out on the exam anyway. It's not like you have to memorize the steps. I tell you what I want you to give me. I guess making sure that you're very practiced with identifying the critical value. And then, you know, if you need to draw it, just like we did when we were doing z-tests, if you need to draw it and put your critical region, whether it's one region or two, and then look at where your test statistic is on that distribution to help you understand, am I in the critical region or not? Then you write your decision and make sure when you write your decision after you've done the test that you include the word significantly or not significantly, because now you've done a test, so you've tested your hypothesis. It's a conclusion. If you and include always at the end of the sentence the test statistic with degrees of freedom, if that's relevant, and its value that you calculated. I'll say this out loud, but I almost hesitate to. Don't write the critical value in your conclusion sentence. I don't need that. I can look that up, right? I need the work you did. You did the hard work. Tell me what the hard work showed. What's the test statistic? And then it will say either P less than or P greater than 0.05. P less than 0.05 if it's significant. P greater than 0.05 if it's not significant. Those always go together. I guess another word of advice would just be to make sure that your sentence, which derives from your hypotheses, which I'm not going to make you write, but your sentence should make it really clear, like what was the independent variable, what was the dependent variable, what was being compared here. You know, that should be clear when you write your conclusion sentence. And I think that's kind of it. There's a review worksheet for the exam. There's a PowerPoint for the exam. The formulas and the Z and T tables are all available in Module 9 before you even get anywhere close to the exam. When you click the exam, you'll have 4 hours. And hopefully, last time a couple people had problems with their exams, but hopefully I understand why those problems happened and they'll never happen again. Hopefully. So any last thing? I'll be on again tonight, 1 hour before the last of the 3 debates, and hopefully we go back to regular news one day, right? And so if you want to join again tonight at 8 o'clock Eastern time, and this will be posted, and then I'll post the other one as well in case there's any additional information that's of help. All right?
Thank you. Thanks
You're
for your
welcome.
help.
You're welcome. You guys take care and do well.
Thank you.
Thank you very much.
Bye.
Bye.